Okay, so 10.6, find segment lengths in circles. And it's going to look familiar to the angles that we did in 10.5, but it's a little bit different because now we're talking about the segment lengths. And let's do a window, present. Here we go. All right. So 10.6, find segment lengths in circles. So the first segment type is whenever we have if two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment of the other chord. So if you see these two chords and they intersect, that means those two pieces. So this piece times this piece is going to be equal to this piece times this piece. So in this one, we would have AE, so this part times the other half EB is equal to DE times EC. So this is the first type where we have the intersection. It's a little bit different. Last time you saw this, we did with the arc and the vertical angles arc, and we found that angle measure inside. Now we're not dealing with the arcs or the angles. It's just those segment lengths. So in this first one, I have this piece times this piece is going to be equal to, so then that's LN times NM is going to be equal to this piece times this piece. So JN times NK. All right, so LN has its x plus 3, 2 terms, so I put parentheses. And this piece of NM is x plus 1 is equal to JN is x plus 5 times x. So in this first one, it's going to be FOIL. The left side is FOIL. X times x is x squared. Then I'll have x times 1 is 1x. Then I take the second set and I distribute, or the second term and distribute it to both. So I'm going to take 3 times x will give me positive 3x, and 3 times 1 is going to be a positive 3. That's the left side. So I'm going to go ahead and combine my two middle terms, x squared plus 4x plus 3. So I combined those two middle terms. Now I'm going to do the other side. So this is just distributing x times x and x times 5. So this would be x squared plus 5x. Now it doesn't matter which side you try to take it to. When I try to combine my x squareds, I have to subtract it from one side to try and put it on the other. The x squareds cancel out. That leaves me with 4x plus 3 is equal to 5x. I subtract 4x from both sides, and that means that 3 is equal to x. So I'm finding the length of ML and JK. ML is the entire length. So then ML is x plus 3, but x is 3. So it's 3 plus 3 plus the other length of x plus 1. So it's 3 plus 1. Oops, 1. That means that this was x and this was x. I replaced x with x equals 3. So ML is equal to 6 plus 4. So ML is equal to 10. The next one is JK is equal to, let's see, x, JK. So x plus 5, so then that's going to be 3 plus 5, because x again. And now I'm adding it to the other length. So the other length is just x, which means it's just 3. So that means it's 8 plus 3. So JK has a length of 11. Now these two can be different lengths. It's just the product is equal to the product. So, all right, that's the first example. The next one is segments of a secant theorem. So again, before when you saw that it was outer minus inner divided by 2 is equal to that angle. Now we're not talking about the angles. We're just finding the lengths of the segments. So in this one, you're going to have, now you have to be careful because it's the outer times the whole. The whole is EA plus AB. That's the whole thing. So the outer EA times the whole thing EB is equal to the outer EC times the whole ED. And again, I want to break this up because EA times the whole thing. The whole thing is EA, the outer, plus the inner part, AB, is equal to the outer times the whole, but the whole is EC plus CD. This is a little bit different than the other one. So it's not just the outer times the inner. It's the outer times the whole thing. So you're going to have to add those two pieces together, then multiply it by the outer piece. So for example, if I have this one, so the outer piece is 6. And I want to change the color. So the outer piece is 6. So the outer times the whole thing. The whole thing is that outer piece plus that inner piece. So it's 6 times 10 for that piece is equal to the outer 5 times the whole piece of 5 plus x. So in this one, it's not just combining and simplifying. I'm going to have to distribute to both of these terms. So it'll be, so we'll have 60 is equal to 5 times 5 is 25. 5 times x is 5x. So when I go from here, I'm going to subtract 25 from both sides. That'll give me 35 is equal to 5x. Then I'm going to divide both sides by 5, and I'll get x is equal to 7. For this one, I was just finding the value of x. So now that I found the value of x, I'm done. I have x is equal to 7. So this one is the tricky one because it's not just piece times piece. It's the outer piece times the whole thing, and you have to add those two pieces together, whether it's just numbers or you put it in an expression of 5 plus x. This one's different. So the first one was a secant and a secant. This one's different because now it is a tangent with a secant. And the difference is going to be that it's going to be the tangent doesn't have an inner piece. So it's just EA times EA, and that is going to be EA squared is equal to the outer piece EC times the whole thing ED. So again, I can think about it as EA times EA, that's what EA squared is equal to EC times, and I have to add these two, and it's going to be EC, that outer piece, plus that inner piece of CD. Okay. So this one, oh, and this one gives you, gosh, that's right. I wanted to do number 15. Here, let me, give me 1 second to, okay, let me see if I can just fix it. So what if I switch the x here and the 12 here? And I won't give you any problems that would be similar. So this one would be the outer squared. So this is RQ. Let me write that down. RQ squared is equal to RS times the whole thing of RS plus ST. This is going to be the whole RT. Okay, 14 squared is equal to RS, which I changed to 12, times X. But it's not just outer times inner, so it's not just 12x, it's 12 plus x. Now let me write my calculator. Okay, 14 squared gives me 196. Is equal to 12 times 12 is 144. 12 times x is 12x. So 196 minus 144 gives me 52. And divide both sides by 12 and 4.3333. Now this didn't work out perfectly because I changed the problem, but if I didn't, then you would have to remember how to factor and solve. And we're not going to do that. So this is just the example. I think in the last year's notes, I changed it to I think problem 15 from one of the assignments. So this one is going to be different from last year's example because I just changed the x and the 12. So just to go over some more of these problems, again, these two are chords intersecting, which means I'm going to piece times piece. This is the one where you don't have to add them together. So it's going to be x times 12 is equal to piece times piece, which is 10 times 6. All right, so it's going to be 12x is equal to 60. Divide both sides by 12, and you get x is equal to 5. So this one is piece times piece, so 10 times 18 is equal to this piece times this piece. There's two terms, so I'll put 9 times x minus 3. X minus 3 in parentheses, there's two terms. So this turns into 180 is equal to 9x minus 27. 180 minus 27 is 153, and then I'll divide that by 9. So first, hold on. I'm going to add 27 to both sides. I did that wrong. So 180 plus 27 is 207. And dividing both sides by 9 is 23. Okay, and this one, piece times piece. So x times x plus 8 is equal to 6 times 8 is 48. Oh, 6 times 8, I just did that in my head. But okay, so x squared plus 8x is equal to 48. Now see, if you get this type of problem, that means you're going to have to remember to factor and solve. So then you would have to have x squared plus 8x and then move this over to the other side. And these types of problems we're not going to work on. So I'm not going to make you remember. But if you did, you would have to find two factors that equal negative 48 and that add to get positive 8. That's not going to work. Then that would be the quadratic formula. But again, I'm not going to waste time. We're not going to have problems like that. I want to assign you problems like that. This one, okay, remember this is the outer times the whole. So the outer piece times the whole. So 6 times, it's not 6 times 6, and it's not 6 times 10. This time it's 10 plus 6. The whole thing is 10 plus 6 is equal to the outer piece 8 times the whole 8 plus x. All right, so we'll have, this is 16. 6 times 16 is 64. 8 times 8 is 64 plus 8x. Right, 16 times 6, no, I think I got that one wrong. 16 times 6 is 96. All right, subtract both sides. I'm going to subtract 64 from both sides. You get 32 is equal to 8x. Divide both sides by 8, and x is equal to 4. All right, again, the outer piece times the whole. 5 times 5 plus 7 is equal to x times x plus 4. This one is also going to give me a quadratic because x squared and 4x. So I'm not going to continue this one. That's already. So let's not do that one. Let's see. Is this going to, yep, this one's going to give me a quadratic too. Darn it, you guys. I hope that you understood this one. I hope that was enough. If it's not, then email me and I can give you more examples. The next one is this one's also going to be a quadratic. So when this x is on the outside, I know it's going to be x squared is equal to 9 times 16. So let's try it. So x squared. So this p squared, because it's a tangent, there's no two parts. So it's x squared is equal to the outer piece times the whole 9 plus 7. All right, so 9 plus 7 is 16. What is 9 times 16 is 144. This one actually works out because I don't have that bx term, that middle term. So I can take the square root of both sides and x is equal to 12. That worked out. All right, so the outer piece squared, 24 squared, is equal to the outer piece 12 times the whole 12 plus x. So 24 squared is 576, is equal to 144 plus 12x. I distribute to both of those. 576 minus 144 is 432 is equal to 12x. Divide both sides by 12, and 36 is equal to x. All right, so this next one, let me do it in purple so you can see the difference. All right, so the outer, I'm gonna need more room. Let's do this. Didn't I do it? New page. Here it is. Okay. Of course. All right, so then this one. Okay, so the outer piece times the whole thing, x plus 12, is equal to the outer piece squared, x plus 4 squared. That's going to be x plus 4 times x plus 4. That is FOILing. So on the left side, I just have to distribute. X times x is x squared, and x times 12 is 12x. For this one, I'll have x squared plus 4x plus 4x plus 16. Combine those two middle terms and you get x squared plus 8x plus 16. So it doesn't matter which way you go. When I try to combine those x squared terms, they cancel out. That leaves me with 12x is equal to 8x plus 16. Subtract 8x from both sides, and I'll get 4x is equal to 16. Divide both sides by 4, and x is equal to 4. Okay. All right, so this was 10.6. It is a little hard just because of the outer times the whole, and the piece that I see that most students get mistakes on is that you don't do it outer times the whole. For this one, you would just do x times 12x, which would not be correct. So it wouldn't be x times 12x because it's the outer plus the inner piece to make the whole. So this wouldn't be correct. Make sure you remember that it's the outer plus the inner for the whole. All right, see you back in a little bit for 10.7, and then that'll be the last section, 10.7 for chapter 10. Let's go back here and stop recording. Or here, stop presenting. So just let me know if you have questions. I can pull this program up when I'm home. I can help you through it. Yeah.